All right, so there's other things we can look at with respect to these quantifiers. The next one is logical equivalence, and this may be slightly takes a little more thought to come to grips with. But for example, for all x, p of x and q of x. So this is a proposition. And what this means is for any x that we pick, p is true and q is true. And so this is certainly logically equivalent to for all x, p of x, and for all x, q of x. And if you kind of think about it, what is this saying over here? This is saying for any x, p is true, and for any x, q is true. And this is saying for any x, p, and q are true. That's certainly going to be the same thing, right? Because, well, think about it, right? But let me show you a different one. There exists an x such that p of x and q of x versus there exists an x such that p of x and there exists an x such that q of x. These are not logically equivalent, right? This is saying that there is a particular x for which both p and q are true. This is saying there's an x for which p is true, and there's also an x for which q is true, but it could be a different x over here versus over here. So, homework question, you'll be asked to find an example of this and explore it with a particular instance. We can also say the negation of there exists an x such that q of x is logically equivalent to for all x, not q of x. Right? And this says there's not an x for which q is true, so for all x, q is false, and we saw that in the previous video. So we can play around with these things. The other thing we can do is we can nest these. So we can have nested quantifiers. And for example, we can say for all x, there exists a y such that p of x. This is saying for any x, sorry, let's do this differently. For all x, there exists a y such that some proposition of x comma y is true. This says if we pick any x, we can always find a y for which this is true. And so for example, for all x, there exists a y such that x plus y equals 0. Is that true? If we pick any x, let's say x is equal to 5, is there a y such that 5 plus y is equal to 0? Yes, y could be minus 5. This is always true. On the other hand, there exists a y such that for all x, x plus y equals 0. This is saying we can find one particular y such that any value we add to it gives us 0. And that is absolutely false. And so we can nest these quantifiers. We can say things like for all x, for all y, some proposition of x, y, and so on and so forth. And this is an example where the order of the two quantifiers can be significant. So we'll have some homework questions that mess around with this also. All right, that's it for this video.